So today we're going to be learning about how to graph a quadratic function. So the quadratic functions we actually did examine very shortly when we did our factoring unit, but what we're going to be learning to do today is how to graph them by hand, which means just using your graphing calculator or the Desmos tool. So just giving you a heads up on the classroom, I did post in the extra resources a YouTube video that I found from Desmos that tells you how to convert your equation to a table, which is actually very important for this unit because we need to know how to examine our table of values. So the quadratic equation is written as y equals ax squared plus bx plus c. This just means that they're numbers with our variables. So a is a number, b is a number, and c is a number. Not all of them have to be there, but that a always does, and we'll see in the next few days. The equation has a degree of 2, which means that's your exponent. Your highest exponent can be a 2. The minute it's not a 2, it's no longer a quadratic. The graph of this equation is called a parabola, and we say that parabolas are functions because they pass the vertical line test. We're going to go over what a parabola looks like shortly. There are 2 types of parabola shapes. When a is positive, the parabola opens upward, or just up. And we say that the curve reaches a minimum. You're going to be seeing these words a lot. They pop up on the regions, they pop up on our tests, they pop up on our quizzes. So when our parabola opens upward, we say it sort of looks like this. And we say it's a happy parabola because it looks like a happy face. And we can see that it has a minimum because look, that's the lowest point it will ever reach. So if you want, write down the note happy. Now we look at the word at negative. So when a is negative, so our first term is negative, the parabola is actually not going to open upward, it's going to open downward. Which means that our parabola is actually going to reach a maximum this time. And here's what our sketch would look like. It's going to look the exact same, it's just going to look flipped. I'll do it in red again. And if we draw in our little eyes, you can tell it's a sad parabola. So it's going to reach a max. All right. So there you have it. That's some of the key features we're going to be looking at when it comes to quadratic functions. So we also have these things called X-Intercepts. They are known as our roots or our zeros. You don't have to label all of this information down here whenever you're graphing. Do not have to label. But this is key information you will typically have to find because it helps you approach the question, especially when we look at the real world situations. So X-intercepts are also known as our roots or our zeros. We also call them our solutions. Sorry for the yawn. But here are the key parts of the parabola that actually do play a key role. Our vertex is where we turn. So we want to look at our parabola and see where we physically turn. So I'm going to zoom in on my parabola. And I'm just going to draw. It's going down, 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 and then boom, it turns. So we say that this has to be our vertex because we say that's our turning point. Our vertex, if we look at the picture, is 1, negative 4. 1, negative 4. So I'm going to write that in. And this is our turning point. You need to remember that's what it's called. It's our turning point. Now we would like to find our x-intercepts. Remember, your x-intercepts is where your graph crosses the x-axis. So if I look, I cross the x-axis at -1 and 3. We're going to want to get into the habit of not writing x equals -1 and x equals 3. We're going to want to write this as an ordered pair just for today. So -1, 0, and 3, 0. If you write x equals -1 and x equals 3, that's not incorrect. It's just sort of the lazy way of writing it. We want to do things the hard way since we're remote learning, so might as well do everything the hard way. Our axis of symmetry. Symmetry basically means if I fold it over, it's going to land perfectly. So if you have a piece of paper, try to fold it, and you can see that it has symmetry. Because if I unfold it, it'll be perfectly even still. So my axis of symmetry is a line. So here's what we need to know. It needs to be in the form x equals, because it's going to go through our x-axis. I'm going to emphasize it in red. This is our axis of symmetry, and it goes through x equals 1. X equals 1. Okay. We're going to go over how to find that by hand tomorrow. It's actually a very quick formula. The Y-intercept is where our graph crosses the y-axis. If I look at my graph, I cross the y-axis at -3. So I have 0, -3 as my y-intercept. And then last but not least, I want to ask, does this parabola open upward or does it open downward? Well, if I put my eyes in there, I'll put them in green. It opens upward because I have a happy parabola. So this is just some key information you're going to be looking at. It's not always going to be like, oh, what are my x-intercepts, y-intercepts, axis of symmetry? It's going to be sort of like scaffolded. We're typically going to ask you one information at a time. So these are your notes for the first page. Let's go on to the next slide where we actually have to graph a parabola by hand. Okay. So now we're going to put into what we learned on the first page into practice. To graph a quadratic function, give you a heads up, this is all done on the calculator or Desmos. Find the portion of the table of values with the pattern of the y values doubling back on themselves. So for instance, I don't want to see the different numbers every single time. I actually want to see the same numbers. It's normal because these numbers are going to repeat. I want to see the numbers repeat. Graph the points in your table and don't forget to label. So given y equals x squared minus 4x plus 3, I'm going to go to Desmos, or I'm going to go to my calculator, and I'm going to graph it. So taking out my TI-84 Plus Silver Edition that I got in high school for my Christmas, I type in y equals x squared minus 4x plus 3, and I hit second graph. And I try to look. So if I look at my table of values, my table of values for some reason brought me to -5. I hit a 48, then I hit a 35, then a 24, then a 15. Those numbers are outlandish. I can't really draw those in my graph because I typically only go up 10, right 10. So I'm actually going to start at x equals -1. So I'm going to copy my table. And I'm starting at -1. And the number I hit is an 8. I'm then going to use 0. And the number I hit is a 3. I'm then going to go to 1. And I hit 0. Then go to 2. And I hit -1. Then go to 3. And I hit 0. Then go to 4. I'm assuming you see a pattern. And I hit 3. And then at 5, you guessed it, I'm going to hit 8. This is the type of pattern we want to see. We want to see these numbers repeat themselves. So we want to see these numbers repeat themselves, and we just copied our table to the right. So now we're going to go to our graph, and we're going to plot these points. So you should have this table written down. Write this down right now. Hit pause so you can write it, so you can see where I'm plotting. So I'm going to plot the point -1, 8. So I go out 1, up 8, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to plot the point 0, 3, so I go out 0, up 3, 1, 2, 3. Going to plot the point 1, 0, so I go out 1, up 0. Going to plot the point 2, -1, so I go out 2, down 1. Going to go out 3, up 0, 1, 2, 3, 0. Then 4 to 3, so 1, 2, 3, 4, 1, 2, 3. And you're going to see a pattern. And then we go out 5, 8. And we just don't write points, we actually connect them with a line. So you need to make sure that the line is drawn as well as you can. It's not as easy to do on an iPad. But you get the gist. It should look like a U, because it's a U-shaped parabola. So we draw our graph. Now it says we need to draw the axis of symmetry in the graph. Note, it is always a vertical line that passes through the turning point of the curve, which is just another way of saying our vertex. So for instance, if I draw in my curve, my graph going down, going down, going down, going down, going down, and boom, comes back up. This point right here is where my axis of symmetry is. So I'm just going to draw a vertical line going down. I'm going to erase this so it doesn't have as much stuff on my graph. That way it looks clean, not messy. I'm just going to draw a line going straight down through my vertex. And we always draw a dashed line for some reason because it just makes it easier to know that's not really a necessary part of our graph, but it does make up a key role. So we drew in our symmetry. Now it says circle the roots. Remember, the roots are where you cross the x-axis. So our x-axis is the horizontal line. So we look at our x-axis, and look, we cross them right here. I'm going to use green. We're going to circle them. So we circled our roots. If you want, I would also write out what our roots are. You can also look at your table. So your roots are when y is equal to 0. So boom. Oh, too pathetic. Root. Root. Because of when y equals 0. So I can say my roots are 1, 0 and 3, 0. Parabolas typically do have 2 roots or 2 solutions or 2 x-intercepts. So we're going to use our table of values to answer these questions. Where is the axis of symmetry in the table? The axis of symmetry in the table is when you have an y value that doesn't repeat. If I look at my table, my y value doesn't repeat right here. So my axis of symmetry is right here. So it's that x equals 2. Where's the vertex in the table? The vertex is the non-repeating point. It's where your axis of symmetry is. So my vertex is 2, -1. And we said where the roots were. We said it before. That's a repeat question. It's when y equals 0. So our roots are 1, 0 and 3, 0. And I'll write a note here. Where's your vertex? It's the non-repeating point. Okay. And then we ask ourselves, is there a max or a min? Well, this is a happy parabola. So it is a min, because look, it only hits that low point. Perfect. So you can also write, because it's a happy parabola, but the thing is, we know it's a happy parabola. So I'm going to zoom out so you can get a full screen of what the notes look like. You will need to know how to graph these. You're never going to have to not graph these with a calculator. You're always going to be given a calculator. So make sure that you know how to use the calculator keys. Make sure that you do attempt the independent practice. It is a lot. It's only one question, similar to how we just did it. But you need to make sure you know how to graph these very thoroughly. Don't forget to write down one question you have after watching this video. Quadratics are a huge, huge part of the Regents. That's why we cover them towards the end of the year. Didn't predict this would happen, but we'll have to do this remotely. If you have any questions, please don't hesitate to email me or Miss Townsend, but make sure that you are using Desmos or a graphing calculator if you have one. You really need to graph these on graph paper. So the next time mom or dad goes to the store, make sure that you ask them to buy some graph paper. If you have any questions, please, again, don't hesitate to email me, and don't forget to write that one question on the Google Classroom. Have a great day.